I got everything up and running that we need. So today is an open review day. We went over sort of on Tuesday the overview, what you should be working on, what you should know. The main thing to focus on is that review, that PDF review that's there. That's provided by the course coordinators who also write the exam. Did I highlight what was on how the exam is laid out? Let me think if it. I got to get myself in the right. There are 6 multiple choice questions. There's 1 true-false type question. One question with 3 parts, let me put it that way. So there's really 3 true or false questions, but they're all based on a graph that we give you, and you've got to answer some true-false, and that kind of thing is very similar to what's in the review. They give you multiple true-false questions. And then there's 8, 9, 10, 11, 12. There's 5 what they're called open answer questions, which is you're supposed to supply supporting work. And again, for those, work to get the correct answer. If you've got a correct answer, it's boxed in. I will lightly review, do you have some kind of work that shows, I'm not going to get into the details and did you show this step and this step. But if it asks you to take the derivative, does it look like you did that? So I do a quick review. If I look at the answer first. If it's correct, I'm not going to go into detail. If it's incorrect, that's when I go into detail to see if there's your supporting work supports some partial credit, and sometimes could be large partial credit, right? Because if it's a small error that occurred and it got you to the wrong answer, sometimes a small error at the beginning results in an answer being way off, but I could say, oh, everything else was done rightly. So I'm going to look for more detail because I want to find points for you. Okay, so I'm not the one who's looking to take points off. I'm looking to get you as many points as we can. Okay, so it does say I changed some of the wording a little bit. I think I've got 2 exams going right now, so sometimes I get confused by which one I did what to. But I change it to just show supporting work. Which is pretty much what it was. But so there's 5 questions like that, and some of those questions have multiple parts. Like they might ask you about, there'll be one on profit, cost, and revenue, a business, because you're all business majors, and it may ask you for the revenue, the marginal revenue, the profit, the marginal profit. So it's in it does it in steps. Just go ahead and do that. Occasionally, I get someone who will do all the work. They kind of figure what it is. That's fine. If it's all there, I'll find it. But there's space there, and there's sometimes A, B, C, and D parts. So, but that's the exam. So 12 total questions. But remember, question 7 has 3 parts: true, false. 6 multiple choice. You don't have to show work for the multiple choice, but it's helpful if you get it wrong and your supporting work shows that you've got some understanding. Okay. Questions? Oh, good. Let's go. Back to sleep. No, can't go back to sleep. Homework is not due till Tuesday night. I can also do individual extensions, but it'll be best if you have it completed by the day of the test. However, if you don't, I don't mind extending it because it will also help you when you go to the final. So I don't mind pushing it. So I think you can still review them after the due date, but if you still want to finish them, again, it's not a lot of points anyway in comparison to what the tests end up counting, but just send me an email or contact me in some way. I have no problem with extending it, but if you can get them done by the time we take the test, that's probably going to be best. Tuesday morning, right? This is Thursday. I forget which day So Tuesday morning, we come in, and if you can get here 5 minutes early, that'd be great. I'm going to start passing out the exams right away. If you want to come, I'll still be here at 7, so we can answer questions and stuff, but pull up the solution guide. And while I do have the homework pulled up, so we could take a look at a few homework questions, but again, the review that they've provided is more like what the exam will look like. It'll be paper pencil. It's not anything to do with WebAssign. So it's going to look, the questions are like this, very much like this. And again, if any of them, or any topic, it doesn't have to be a specific question here. If you wanted to talk, like I've been asked several times about the square root function. How do you do that? Because, you know, that one's a little tricky. It's a fractional. I'd be happy to go through a couple examples with that. Whatever you want, but it's, you all are the ones that drive it. So just, or if you want to just work individually, and then we can do tutor session. We can do that too. But you let me know. Yes, sir.
On the tangent lines, like review, I know you showed us how to find, the tangent line and the equation of that. So like the following ones, like one of them is a point. The first one is just x equals 2, but one of them is find the equation of MAT210. So it's like a how do you do that?
Very good. Actually, that one's easier because they give you the y value. But sometimes when they're trying to help you, they actually make it harder because you haven't done it yet. Very good, very good. So let's see now we could do it with the calculator just like we did the other one. We would just put in x equals 3. We just sort of ignore the 7. You'll see the 7 will come up as a point, as a y coordinate. So x squared minus 2. Let me go ahead and I pulled up the calculator too. And again, I'll try to, I've lost my cord for my little camera, so I got like 3 different work areas in my house, and so it's in one of the work areas trying to clean things up. And when I do that, I put things in a special place, and so I got to find that special place I put my cable. And then, so those of you who do the Casio, I'll show you how to do this one. Because you can, so what was x squared minus 2, not that minus, it's subtract 2. So we could, let's go zoom number 6. There's what it looks like. We can go second draw, and we're going to do the tangent line, number 5. And then it's just waiting. We put in the x coordinate, so it was 3, 7 was the point they gave us. We're just going to put in 3, x equals 3. We'll put enter. There's the tangent line. It's going through x equals 3. And here's the equation of the tangent line, is 6x minus 11. It doesn't show us what that is, but that coordinate, if you kind of come over here, that actually would be, that point that's flashing is actually 3, 7. Okay. Let me show you if you wanted to do this by hand. The way that you go about finding that tangent line. So the first thing you would do is you would get the derivative. So the derivative of the function. Derivative of x squared will be 2x. Derivative of negative 2 is 0. Good. So it's a constant. So that's our derivative. That's going to give us the slope of our tangent line. And remember, tangent lines, it's a line. Its slope, its equation will always be y equals mx plus b, where actually the slope, the m, is really the derivative at that point, right? The derivative at 3. This x is part of the equation of the line. We are also going to have to find the y-intercept, which has nothing to do, well, very little to do with the equation. So anyway, I plug in 3 to the derivative. That's going to give me the slope of the tangent line. and we get 6, and remember that equation it gave us was 6x. So what we have is y equals 6x plus b. So this is going back to algebra now. And then what we need is we've got a slope and we need a point, and they gave us the point 37. So that means when x is 3, y is 7. That's a point on the graph. Okay, and you can see if you plug in 3 squared is 9, 9 minus 2 is 7. So you could have got it that way. That's a lot of times that's like up here, they just give you the x value and they're expecting you to figure out what the y value is. This one, they were helpful, they gave you it to you, but that wasn't. So we plug in 7 for y, because that's what it is. We plug in 3 for x, and then we're going to be able to solve for b. And we're going to see we should get, what, negative 11, I think it was. So that gives us 7 equals 6 times 3 is 18. Subtract 18 from both sides. And 18 and negative, or 7 and negative 18, that gives us that b equals negative 11. So the equation of our tangent line, y equals 6x minus 11. So it can be done without the graphing calculator, period. So if you don't have a graphing calculator, you're not out in the woods, you just got a few more steps, right? You find its derivative, plug in the point, that gives you your slope. You need a point on the curve, the point of tangency, so they always give you at least the x, and in this case they gave you the x and the y. You take that point, plug it into the linear equation for the x and y, that will give you your y-intercept of the linear equation, of the tangent line, right? The thing I like about the graph is when you do this, this is all abstract, and you're not really certain what you have. At least I never was. When I look at this graph, I see the tangent line is something new. It's a new creation. It's not the curve. It's not that x squared, right? I've got the parabola, and I can see, yeah, it's going to have a y-intercept down here of negative 11. Okay, so it all starts to make sense. I get a visual of it as well. That's why I go this route. It's not just because it's easier, although it can be once you get used to it, but it's also more powerful. And it's a tool that if you use this kind of a tool for your decision making, your decisions are going to be based on better data, not just numerical data, graphical data, and tables and stuff. So that's why I go that route. Too many math teachers are still caught back in 30 years ago in teaching so we still got chalkboards here. I haven't had a chalkboard in the classroom in a long time, or at least whiteboards, right? But anyway, we got technology, let's use it. I'm just waiting for the day when they'll open it up to cell phone usage, because if we get all these apps on our we always got the cell phone with us. Yeah, I got it down there. We always had that with us, right? Why not put everything we need on it? So what if it's got internet? We always got it. Let's use it. They don't like me. So anyway, good question. What else? Anything. Everything's a good question. Yes.
Yeah, for some reason I'm just really thrown as far as for like what to do with this.
Which one?
Number 4.
So interpret the sign. Yeah, it's kind of a vague question.
So that's asking the derivative of that, right?
Right. And so what's its sign? The sign is negative first, and then it goes to positive. That's all.
Well, what I say, it's because if I'm doing that, saying negative, then no slope,
then zero,
or 0 rather,
and then positive. Yeah, it goes.
the
Yeah,
answer?
that's fine. Yeah, I don't know what their exact answer was, but it's not a well phrased question.
Yeah, okay.
But that's on the test. It would be a better phrased question. But that's what they're looking at, is what's happening to.
It's like that, but it's like they're asking for like the process and stuff. Yeah.
Right.
Kind of overthinking it, but I'm like, we don't have any numbers to work with.
You don't. Yeah, exactly.
So if it said graph, could I just do like anything that kind of looked like that?
Well, the graph of this will be a straight line. It'll be negative here because it's a graph of the slopes. So it's actually going to be a straight line. It'll go here and then go through. In fact, you just question came up. What number is that? 4. So 4, and it's it was kind of a vaguely asked question, but I think this is a good one, and I can show you a technique that will help as we go forward too. So it gives a graph. This is the function. Then it asks us to interpret the sign of f prime, of the derivative. So again, these are tangent lines. It's not a well asked question, but it's just saying, okay, the signs of the derivative, or the sides of tangent lines, start, as you can kind of see, they start out negative, they become 0, or 1 becomes 0, and then they become positive. I think that's a good enough answer. I'm not sure what they have in there, and I'm not even going to look because it doesn't matter to me. This question's asking, do you understand what's happening to the sign of the derivative? It then asks us to graph it, or sketch a graph of the derivative. Now remember, if we've got a parabola, that's an x squared. If we take its derivative, what do we get? We get an x to the first power, which is a line. What I'm going to show you is that you can actually, it's a little complicated with the TI-84, but you can actually get the TI-84 to graph not the tangent line. So we've got a tangent line at a particular point, but we could actually graph the whole derivative, the derivative as an equation. Now remember, we've got the derivative as an equation. The derivative as an equation is 2x, right? 2x would go through 0, 0, and would be aligned with the slope of 2. So let me go back here. I'm going to ungraph this, just so, because I don't want that tangent line there confusing us. And then here I'm going to actually graph the derivative. Now the way we do that is there's this math key. Let me clear this stuff so that you can kind of, you'll be able to see my key press. So I'm going to, what was I going to do? I'm going to go to the math key, and in the math key there's something, number 8 is in derive, which is the derivative. It will actually find the derivative for us. Now it doesn't do it with an algebraic system, so it's not going to algebraically tell us what it is. That's what a CAS calculator would do. That's why they don't let you use those on the test. But watch what happens. I'm going to put this, it's actually going to graph this for us. D what? dx, right? We want the derivative of x. What do we want the derivative of? We want the derivative of whatever in y1. And now this is where it gets a little complicated. How do we get y1 in there? Well, you can go to what's called vars for variables, and then you go over to the y variables. We're looking at functions. So we enter, and actually, watch this. If I do this, it's now got y1 in there. So whatever I put in y1, y2 is going to be the graph of its derivative, almost. And then it says x equals what? I could do it at a point, but what I want is I want to keep x a variable, so x equals x. And when I go to graph it now, I see the function, and now I see its derivative. That's what the derivative would look like. And again, I think this is powerful. Casio will do this too. I'll have to figure out, but you call up the function.
So how did you get 2 as the constant in that?
Recognizing that that's x squared. If that is just x squared, they don't tell us that, but I know it's a parabola, and thinking x squared will give me 2x. That's going to be a line. So what I think is I've got a parabola. Its derivative is going to be a line. So when I sketch the graph is going of the derivative will be just a line, and it's different, right? So this is where the line is negative. That's where the slope is negative. Okay, and you can kind of see. It kind of tells us the slope actually is always increasing, right? Because it becomes less negative. So that's what this is telling us. It's becoming less negative. Here at 0, we have a minimum. The derivative becomes 0. And then on that other side, the slope of the tangent lines become positive. They change, but that's what that derivative is. We're going to use this a lot, especially as we go forward. If we have an x to the third function, what we see is its derivative will be a x squared function. If you have an x to the fourth, its derivative will be an x to the third. And we'll start, when we start talking about maximums and minimums, we'll see how we can use the derivative function maybe as an easier way, because the x-intercept on the derivative is the minimum or the maximum of the original function.
So because it was x squared, you knew it would be a line. If it was x to the third, that
Would be a parabola. Exactly. So it's always just like we're subtracting one from the exponent, so you know whatever the graph looks like, the derivative graph will look similar, but it'll be one power lower. Okay. And again, I only know that because I get paid to do this stuff for 24 years, and I didn't know it as a student. I was, it takes a long time. And again, that's the thing. The thing you guys are probably struggling with is you have one math class a year, maybe. And maybe you didn't have a math class for some semesters, right? And you come to this class, and we expect you to remember everything about fractions, everything about algebra. We just kind of go in and say, all we're doing is teaching you calculus. Remember all this other stuff you had? Well, some of you, it might even be like 5 or 6 years since you had a math class. When I came back, it was 13 years. I came back to school when I was 38. I've been out for 13 years. Yes, I did some math stuff. I was in financial planning, but going to a math class was a lot different. So there's a lot you have to bring back to your memory, and there's also some of you are like me. There's things you learned wrong the first time, or you had a misconception that you used for a long time. You never forget it. You never forget the wrong mistake, or it's hard to. You maybe find the right way, but along with the right way is also the memory of the wrong way. And so that's the other part you're struggling with. But you'll get there. We'll get there together. And again, the goal I have for you is that you find ways to apply this in your fields. And again, if you're in finance, you're going to apply a lot of it, maybe. If you're in marketing, maybe some, but maybe not as much. Administration, you're probably going to focus more on the HR requirements and stuff, but you might still need some of this math. Okay, so we'll work with it. What else? I'm just talking to give people time to think of questions to ask, or keep working on what you want to do. These are all good questions. Yes, sir. Come up there. Number 10. Oh, sorry. Number 10?
Yeah.
Sure. You got that. There's been a request for number 10. There was one similar I remember in the homework, so it's probably a good one to take a look at. And again, I've gotten, let's see, 0810 where, oh, they kind of numbered this kind of weird, didn't they? I didn't realize that. So, okay, here, this one. So I guess they did it by section and starts renumbering. So this one is strictly a limit question. So we're not using really we're not using the derivative here, okay? And again, the reason is I tend to read things backwards, and I recommend it highly, because when you go backwards, you start seeing things. Oh, they want the limit here. They want the limit here. And if I'm up here, I don't really know what they want. I got these functions. Am I going to have to take the derivative? There's a lot of stuff going through my head that's going to put me off. And then when I get down there, I've already started thinking about things. But if I read backwards, I know what they want. So I go, so I've looked at it, oh, they want limits. I know where I'm at before I even start looking at what they gave me. So I recommend to read from the bottom up, or the, again, I'm not literally reading backwards, although sometimes I can do it. But let's see, let's go with this. So we know we need a limit. So for the A part, they just want the limit of WT. So now I says, okay, they're just talking about this one. Oh, I see that Twitter's W. So following approximate popularity of Twitter, and so okay, these are popularity ratings. These are the percent that. So now I see. I notice I didn't actually read the whole thing, but I picked out. Okay, I figure what's going on. But the question is, what's the limit as time goes to infinity? What in our business? Because I want you to apply it to your business. Does that mean time is really going off to infinity? No. It just means we don't know when it is, so we plan for forever. It says, but we know it's not going to be forever. It might be 5 years, it might be 2 years, but when it's unknown, we see, let's evaluate it at infinity. So WT, I look at this function. Really, all I have to do is take a look at the largest exponent. Okay? So I just really need 0.33 t squared. If t goes to infinity, what will happen? You're going to square infinity. You're going to get an even bigger infinity, I guess, right? You'll multiply it by 0.33, which would make it a little bit smaller, but it still makes it infinity. That's the thing, is infinity is so big you can't really make it smaller. Okay, this thing is just going to go off to infinity. And what is going off to infinity? Their popularity. So the percentage of their popularity, they're just going to become, if you just let them go, they will continue to become more and more popular. Okay, so that would be the computation. What you can also do with this, though, to understand this, since I've got the calculator up, you can graph this, and I'll show you that you can see it visually as well. We're going to graph the whole function. So come back here, clear. I'm going to leave this here, but I'm going to turn it off so that I don't have to go through. So if I ever want the derivative, I can get it. This was 0.33 x squared minus 2x plus 0.8. So minus 2x plus, what was it, 8.7? Yeah. Then I'm going to graph it. I see I've got a parabola. I could zoom out maybe to see more, right, because I want to see what happens at infinity. But I can already see, remember, the limit is the y value of where this is going. I know a parabola that's going up, it's going to keep going up. So I can say as x goes to infinity, y is also going to go to infinity. I could also zoom out. And I see, yeah. So that's, I can visually see it. And maybe that's a clearer way instead of just abstractly talking about it. Probably the question B is now it's a ratio of the two, so we write them as a fraction. So let me clear this off. So just think it's going to be WT over L of T, right? So it's a fraction. Instead of rewriting them, I'll just make it into a fraction. And when we have a polynomial divided by a polynomial, again, what do we just have to consider? The largest exponents, again. And again, you could graph this. You could graph this, and you would also see that it's going towards this value. But what is this? This is 0.33 t squared over 0.04 t squared. Again, the t squares are going algebraically cancel. They become 1. So now there's no variable, right? It's just going to go to 0.33 divided by 0.04, which actually ends up being a bigger number. So that's 33 times 4 is 120 something. 0.3. Let's go ahead and do that. So I'll go back to, let's see, what do I want to do? Clear 0.33, and you don't. It's not. I'm not even graphing it. Divided by 0.04 is 8. Well, I was way off. 8.25. So, and what does that mean? So if they ask you to interpret it, well, that means Twitter will be 8 point, whatever that number was, 8.25 times as popular as LinkedIn in the long run. It might not be right now today, but again, you could put it, if you need it at a particular time, you put those values in, you plug it in, you get it. And again, you could also graph this. Since I've got half the function here, let me insert, I'm going to put in a parentheses around this, parentheses around that, and then I'm going to divide it by, what was the function? 0.04 t squared, oops, parentheses, 0.04 x squared minus 2.6 or 0.26 x, what was it, plus 5 plus 0.67. Okay, oops. And so if I graph this, let me zoom standard. In here, so I want to see what happens at infinity. Obviously, it's higher. Let me make my graph, obviously, at y max. Let's make it like, say, 50. Let's see what happens. Okay, so it went up, comes down, and what I'm thinking, this one doesn't trace along. Let me let's make the x bigger. Let's make it like 100. And so the one way to do this is I can see what is the value. So I go second calc. I'm going to look up a value when x is 99. It tells me at 99 it's 8.29. Right? So if I go further out, remember it's supposed to get close to 8.25 out at infinity. So it's getting there. So here's another way to see, but I could at least see that it's got a horizontal asymptote. It's getting towards some number. I look there. Okay, 8.25 seems right. Okay, so again, but it's less abstract. I can see what's happening. I'm looking at a picture. I say, yeah, it's going to go to a value, and that's what that limit meant. And that's why I only needed to worry about the x squareds, the ratio of the x squareds. Okay. Helps tie things together. So some people, you may not have a graphing calculator. So they ask, do I have to have one? Well, you could take it without it, as long as you figure, your ways. But a graphing calculator is very helpful if you have one, and then you know how to use it. So that's why I, bring those in. Good. Good. Good question. Anything else? We're doing good? Remember, you got over the weekend. I think someone called. I've got a Zoom appointment at 10 a.m. on Friday. It's tomorrow. Someone asked for one. I said, yeah, I could be Friday morning. So if you want to join me, I've got my Zoom link. You're welcome. I'll be there. I'll be online at 10. If you need another time, let me know. Fridays, I can pop on for a little bit. Throughout the time, I'm just doing some work at home, cleaning up and getting that kind of stuff. But I'll be I'll be home. I'll be checking things. I get my emails on my phone, so I'll know if you send me an email, I'll be able to get that within and get back to you whether I can meet or not. But I want to make sure if you've got questions, especially if they're little ones, sometimes if you get them answered, then you build your confidence, right? Sometimes even a little question, you're just not sure about that, then you feel unsure about everything else. So if we can get that little question answered, and sometimes they're big questions, we can do that. And just to tell you, I got a little story, since no one is asking questions. Sometimes, if you're not understanding something, it's sort of better to just move on and say, okay, I'll just miss this one if it's on there. When I was taking calculus, I can't remember if it was Calc 1 or I think it was Calc 2. I had a really good Calculus 1 professor, so I took him again for Calc 2. But I got overconfident. I stopped studying. That's not a good idea. And I went into the test. I was busy with some other stuff, whatever, make my excuses. I didn't study. But actually, I got the highest score on the test, and it was because I didn't study. I looked at the test, and I had no clue what to do. It was a 3-question test. I had no clue what to do on the first 2 questions, so I skipped them. I went to the back. The backside question was actually pretty easy. A guy like me who didn't study could do it. I got it right. The problem was everyone else stuck on the first 2 questions. They had studied hard, but the questions weren't well asked. He even agreed. He says, nobody got those first 2, but they spent so much time they never got to question 3. So everybody had a 0. I had at least 1 out of 3. I thought I was going to fail because I knew, okay, I knew I had that, but I knew I didn't even attempt 1 and 2. He saw that, and I thought, oh, good, I got a great score. He threw that one out, of course, and we did it again. But but it's just kind of look over things. Don't, just because you don't know how to do 1 or 2 things, don't get yourself down. Go ahead. And sometimes it's better to, there's going to be something that you might be struggling with. Sometimes it's better to go back and look at the things that you're confident about and be more confident about them, and that will help you get forward. And then over time, the thing is once we get further down the road, sometimes when you look back, those things you were struggling with make more sense. And that's, throughout this course, we're going to pick up more techniques and stuff. And at least that's always been my experience, is sometimes, even if I do sort of understand things, later down the road, I'll understand it more deeply. Okay? But just kind of, get yourself in the best position you can. Okay, so that's my story. But please do study. It's helpful. But I understand when you don't, because I've been there. Sometimes you just run out of time.